Hey guys, this is Mrs. Gastler, and in this video we're going to talk about angled projectiles. These are the most complicated, which is why we saved them for last. And they're going to take everything that we've talked about so far and put it all into one big thing. And so you're going to be doing a bunch of things at the same time when you solve problems or answer questions about angled projectiles, okay? So the first thing that we are going to do is draw a picture. And if you have not been drawing pictures to go along with your problems, now is a really good time to start, okay? So whatever's going on, starting with a picture is always good. So you've got your projectile, and it's going to be launched at some kind of angle. And maybe it's going to the left, maybe it's going to the right. Who knows? Maybe you're launching it up, maybe you're launching it down. Either way, there's some kind of angle. And you probably ought to know which way that angle is going, okay? Sometimes we launch our projectiles up, and sometimes we launch them downward like this, okay? It really kind of depends. And reading the question is really going to help you figure that out, whether you're launching it upward or launching it downward. And we are usually measuring the angle from this like positive x-axis right here. If we're throwing it the other direction, you know, like this, then it would look like this instead, okay? But usually we go left to right, right? Okay, just like we read left to right. And so this is often what our problems look like. And so that's where we're going to start. Now, thanks to what we've already talked about with the horizontal projectiles that look like this, remember they still follow this curved path. That's a parabola, but this time we're looking at more of the parabola instead of just like half of the parabola with that horizontal projectile. We're going to see like two sides of the parabola, okay? Except for these downward ones, we're seeing even less of the parabola. So with the downward one, we're starting more like here, okay? And we're only seeing the end of the parabola instead. And so, but it's still going to follow that parabola. It's still going to curve even more before it hits the ground. We'll talk about those in a second. Let's talk about the ones that go up. There's the ball. There we go. Okay. So this guy is going to be fired up this way at some angle. Okay, and it's going to follow that parabola path, and it's going to hit somewhere. Now, depending on whether or not it's fired on the ground or fired up from a cliff or something like that, maybe it hits at the same level. Maybe it's from a cliff and it's going to continue on downward some more before it hits the ground over here. We don't know, okay? But this is where we would need to make some sort of list as to what is going on in our problem to figure it out. And just like in the horizontal projectiles, we're going to have to split the motion up. So that's the first thing that I would tell you after this, okay? After you draw a picture, splitting things up into the horizontal and the vertical is definitely the next thing to do, okay? And just like we had that little valve before where only the time can get across, okay? We've got the little valve here that only time can pass. This is our time valve, okay? Only time can go through that valve here. That's the same thing here, okay? So this happens, there's the Y's up and down, and then there's the horizontal thing that happens, and they're separate, but they do happen at the same time. That's the same situation here. So we're going to have things going on in the X direction. And there's still some things that are always true. So that acceleration in the X direction is still always 0 because gravity is always pulling you down. And so I'm going to write always here, just like I did on the horizontal one, okay? And the acceleration in the Y direction is still that G, that negative 9.8 meters per second squared, or down, you know, however you wanted to write it. That is always the case, okay? So you could always write that, and it'll always be correct. You can use 10 too. You don't have to use 9.8. You could use 10, and it would be fine. Now, in the horizontal ones, we always had that the initial velocity in the Y direction was 0. That is not the case here, okay? So when you get an initial velocity in this one, this is where we're adding one more step since the horizontal ones. You have some initial velocity at some angle. In this situation, let me grab my other pen here. In this situation, we're going to have to find the X and the Y component. Do you remember that one? That was one of our previous lessons. So now we have Vx naught and Vy naught, okay? That's the difference between the horizontal projectiles and the vertical projectiles. So now we have Vx naught, it's no longer whatever the initial velocity was. Now we have to do the component stuff. So remember, this one is the adjacent side, so that's the cosine, v naught cosine of the angle. And this one is the, what do you call it? Opposite side, so that's v naught sine of the angle. And so we're going to write v naught cosine right here. And this one is vy naught, and that's v naught sine of the angle. Now, I could write always next to that. I don't know what the numbers are, so it's not always going to be the same numbers, but this is always going to be the right formula to be able to find those, even if, whoops, where'd my other picture go? Even if my angle is below, I'm still going to be using the v naught. So here's my v naught and here's my theta. Oops, I didn't line that up very well. Okay, so v naught x is still going to be v naught cosine of theta right there, and v naught y is still going to be v naught sine of theta. I just have to remember that this is down, so it's going to have a negative value when I put that in there, okay? So, and that's something to pay attention to because acceleration due to gravity is down, okay? So there's my projectile motion right there. My x direction is going to be the range of my projectile here. They call that the range. I know that's really confusing. I was talking to some Algebra 2 students recently, a particular one, about how annoying it is that they use range to talk about the y values, and they call the x values the domain, and so he'd rather call this the domain of the projectile instead of the range because it's confusing. And if that bothers you, that's just what we call it. We call it the range. How far you should shoot a projectile is the range. And that's a physics term, not a math term. So separate those in your head and you'll be okay. Okay. So the distance that it follows in the x direction, that delta x, is whatever the distance is. Okay. We call that maximum distance. We call that the range. Okay. There's actually a formula for that, which requires a lot of trig identities, which you may or may not have learned. I know they don't go over those in geometry, but they do go over those in pre-calculus, so you may have not learned those yet. I don't remember if we're going to go over the range formula or not. I don't think you have to know that for the AP Physics test, and it's not a pretty one, but it does work out in the end. So, but there is a formula for that. It might be in the textbook, actually. You should look. And then there's the time. The time that happens is the same as the time over here. That's the link between them. So these are the same time right here. That's the same time, okay? And then there's some delta y over here, and there's like a maximum height that it reaches. We just call that the maximum height. It doesn't have any kind of special name, okay? But you have to be careful with the delta y, because if you're up on a cliff, the delta y that you go up can also go down, and so that's rather interesting. And then just like in the vertical projectiles, there's some symmetry going on in here as well. So I'm going to note that over here. There's some symmetry going on as well. So at the same height, it's going to have the same vertical speed. So if the vertical component, so the v naught or the vy is going to be the same at the same height. It's just going to be in the opposite direction. But also, if you run across any questions that are asking you about the speed of the projectile and it doesn't say vertical or horizontal, it wants you to find v. So it's going to be asking you about the magnitude of the velocity vector. Okay, so if it says, with what speed does it hit over here? It's asking you to find what VF X and VF Y are, and then find VF. Does that make sense? VYF, VF X. And since VX isn't changing, it's just going to be the same number. So you just have to find VF. There's an F in there. Let me write that better. VFY. And then you just have to find the resultant, that hypotenuse of that triangle again. And so VF is going to be the speed. It's the magnitude of the velocity vector at that time. Okay, so pay attention to what the question's asking to make sure that you're answering the question that it's asking. Okay. So those are the things that you need to pay attention to if you're doing any kind of calculations. And then if you're thinking, if it's asking like conceptual questions, you're going to have to think about all the different things that you've been thinking about so far. So remember, you can separate this out. So you've got some vertical motion, you've got some horizontal motion. What's going on with your projectile? What's important to be thinking about? What's the same? What's different? If you change one thing, what's going to happen to the other? It's all just pieces that we've put together into one single motion at the same time, okay? If you have any questions, make sure you ask your teacher. Thanks for watching.